Saturated and unsaturated. What do you think of when you hear the word saturated? Pardon me? Wet. Like a sponge is saturated with water, right? Full. Completely full, right? So sometimes what happens is, back in the days when it used to rain, it would rain and the ground would get saturated. They say this, the ground is saturated, watch out for flash flooding, right? Because when the ground is full of water, when it can't absorb any more, any water that comes down just runs off, right? And then it puddles up in the streets and goes into people's houses and makes a mess. We'd kind of like a mess like that right now, wouldn't we, in this drought? Saturated means full. A solution can be full also. So a saturated solution contains the maximum amount of solute at a given temperature. So when we look at a curve like this is for sodium acetate. Right on this line is the saturated solution. So at room temperature, just over 80 grams per 100 grams is saturated. If I add more sodium acetate, it will not dissolve. It'll just sink to the bottom. You can stir all you want, it will not dissolve. It is saturated. An unsaturated solution means that there's room for more. It's not quite full. So anything below this line is an unsaturated solution. If I add more, it will dissolve. That's what an unsaturated solution means. And then there's this part above the line. That's called a supersaturated solution. Well, actually, let's just look at the graph for a minute. So at room temperature, we can have about 85, well, that's more like 82. 82 grams in 100 grams of water. What if I have, I don't know, maybe 130 grams in 100 grams of water? That doesn't seem possible, does it? Because the most that will dissolve is 82. If I put 130 into the beaker or whatever it is and stir it, we would expect that everything above the 82 would just fall to the bottom and sit there. And that's what would happen if you put it into room temperature water. But if we take this solution and we heat it up, let's say we heat it up to 90 degrees. At 90 degrees, can we get 130 grams to dissolve? Yes, we can. We definitely can. And then as the solution cools, normally what would happen is when it gets to, what is that, 90 degrees here, we would expect to see some of that precipitate out because as you cool down, the solubility decreases. But some substances, like sodium acetate, will form what's called a supersaturated solution. It reminds me of Roadrunner. He'd run off the cliff, right? And he didn't fall until he realized that he had gone off the edge and was high above nothing, right? And that's kind of what a supersaturated solution is like. It hasn't yet realized that it should precipitate. Not all substances can form supersaturated solutions. They are unstable. So you make a saturated solution at an elevated temperature and you allow it to cool slowly without disturbing it. But it is unstable. And so one tiny crystal, sometimes a bump or just touching the surface, will cause a massive crystallization. So here's a picture of the supersaturated solution. They're going to just drop a tiny crystal in there, and you can see the crystals forming, and then it gets almost solid again.
Can't you do that with water? You put it in the freezer, and then you take it out at a certain time, and you smack it on the table, and it'll immediately
You can supercool. You can supercool water, and that happens with soda sometimes, which is mostly water. It's maybe been in the freezer, or it's been in a part of a refrigerator that's too cold, and like one of those one pint bottles, you can see through it. Oh, it's not frozen. And then when you open it, it just freezes. You're like, what's up with that? That has to do with the pressure affecting the freezing point of the water. So it appears to be a similar effect where you had a liquid and all of a sudden things have become solid, and yet it's actually a very different phenomenon, but very interesting also. Before I get to that, we're going to watch a video. So here's an example. A sodium acetate solution contains 80 grams of sodium acetate per 100 grams of water. Determine whether the solution is unsaturated, saturated, or supersaturated at each of the following temperatures. So what we'll do is we'll look on this graph and we'll find 80. So this is 100 and this is 50, 60, 70, 80. What color am I writing with? That's a good question. How about red? So 80 would be this line. That's 80 grams per 100 grams. So at 0 degrees Celsius, is my red line above or below the curve of saturation?
Above.
It's above. So that solution would be above would be supersaturated. So that's going to be supersaturated. How about at 15 degrees? Where's 15 right here? It's right on the line. So that's saturated, and at 45, unsaturated. Any questions? Usually we deal with unsaturated solutions.